everybody, and welcome to the first lecture here up in Unit 7. Unit 7, the primary topic is atmospheric pollution. We're going to delve into two of those topics, sort of an introductory uh, topic to air pollution in general, and then we'll delve into some specific air pollutants with topic 7.4. The enduring understanding from Unit 7 is that human activities have physical, chemical, and biological consequences for the atmosphere. Reading. I'm going to keep hounding you guys. Make sure that you don't solely rely on Mr. Huderberg to give you all the information you need. Read the corresponding sections of your textbook, right? I'm not going to hit every little detail, and those of you who are really interested in expanding on your knowledge beyond just what Mr. Huderberg tells you, read pages 600 through 609. That will accompany what we talk about in this lecture nicely. So first of all, let's do some review of the atmosphere itself, some helpful things to remember. We've talked about in previous units and on more than one occasion the general composition of the atmosphere, but let's remember that the atmosphere is nearly 80% nitrogen gas, about 21-ish% oxygen, and the remaining of that 100% is a mixture of gases like argon, carbon dioxide, and a bunch of other trace gases. All right? And the atmosphere itself provides specific ecosystem services, lots of them actually. Among them are, providing essential gases like carbon dioxide and oxygen for both photosynthesis and cellular respiration. Higher up in the atmosphere, we have the service of blocking harmful solar radiation. Um, the atmosphere, as we just learned about, helps to moderate our climate so we don't cool off too quickly at night and become a giant block of ice. And of course, it does things like redistribute water and the hydrologic cycle through weather events and so on. All right. Now, we've also previously talked about the layers of the atmosphere. Just remember, two most important layers for life are going to be the troposphere, right, where all living organisms live and occupy. It's where all of our weather happens. That redistribution of water we just talked about in the hydrologic cycle happens down there. Stratosphere, well, all layers are important, but the stratosphere also provides an essential service in that we have uh, our maximum amount of ozone hanging out up there in the stratosphere, and that is what blocks a lot of the harmful ultraviolet radiation. And later in this unit, we'll tack on a couple of Unit 9 topics around ozone depletion. All right, so let's dig into air pollution specifically. All right, so when we talk about air pollution, we're talking about any chemicals, whether they were emitted by humans, so anthropogenically, or whether they have natural sources. Anytime we have added chemicals to the atmosphere, right, then they end up being in high enough concentrations to be harmful. So that could be directly from human sources, the anthropogenic, or it could be something from like um, wildfires, or it could be something like volcanic eruptions. All kinds of natural sources exist for air pollution as well. Anytime the concentration of those pollutants is high enough to be considered harmful, we call them air pollution. All right. And we're going to differentiate two primary categories. All right. Uh, so there's what are called primary air pollutants, and those would be substances that are directly emitted to the atmosphere from a source. So carbon monoxide, carbon dioxide, some nitrogen oxides, uh, VOCs, things like that. So basically, there's a pollution source. Those emit certain chemicals directly to the atmosphere. Those are our primary air pollutants. Now, some air pollutants do exist in the atmosphere, but aren't directly emitted by us in that form. All right. And so when this happens, the primary pollutants that we emit, some of them go through chemical reactions after being emitted to the atmosphere to form a new compound. It could still reach harmful concentrations, right? But when it's a new compound that forms as a result of chemical reactions in the atmosphere, but wasn't directly emitted by humans, we call those secondary air pollutants, all right? And there are lots of examples of those. The next diagram shows a pretty good combination. So primary air pollutants directly emitted by humans, those undergo reactions maybe with water vapor or oxygen in the air to form secondary pollutants. So most of our compounds, so here's a couple of examples of acids, so sulfuric acid, nitrous acid, right, that can dissolve in water and fall as acid precipitation. So most of our acid precipitation causing chemicals are secondary pollutants. resulting from things like sulfur oxides and nitrogen oxides that are the primary pollutants that end up leading to the formation of those. Okay, so we do want to make sure we can differentiate those two terms. All right, so we're going to go through the major classes of air pollutants. All right, and these would be things that are accounted for and dealt with and have limitations set upon them through what's called the Clean Air Act, although we will talk about the Clean Air Act specifically later. All right, so we have what's called particulate material, and we'll talk about each of these in turn: nitrogen oxides, sulfur oxides, carbon oxides, hydrocarbons, and ozone. And you might be a little confused about why we're including ozone there. We will clear that up here shortly. All right, so particulate material, we're talking about solid particles or liquid particles, right? So not gases, but because they reach a small enough size that they can become suspended into the atmosphere, right? And so whenever you are seeing the visible air pollution, what you are seeing is particulate matter in its various forms. That could be smoke particles, dust particles, it could be sulfuric acid particles. There's all kinds of different types of particulate matter, but they're solid or liquid particles suspended in the air, right? And if it's visible, we are talking about particulate pollution. So soil particles, dust, soot, lead, asbestos, sea salt, sulfuric acid drops, and then what we are most familiar with here in the Pacific Northwest in the months of July, August, and September, of course, would be wildfire smoke. All right. Now, particulate material can be dangerous for two primary reasons. So usually when they have hazardous air quality warnings, they are measuring directly how much particulate matter happens to be suspended in the air at a certain time. All right, and it is dangerous. One is sometimes the particulate matter itself might be toxic or contain materials that could be carcinogenic. By the way, carcinogenic means it's linked to increased rates of cancer. Okay, but most commonly we worry about particulate matter because it can get lodged in your lungs, right? So gases, for example, we breathe them in and then we breathe them back out again. That doesn't mean they might not be harmful, but liquid droplets or solid particles, we can breathe them in and they can become stuck in our bronchial tubes or even in our lungs, depending on how small those particles are, and remain there and cause some more chronic irritation, inflammation, really exacerbate things like asthma and so on. Okay, so particulate matter is measured quite regularly, and most air quality concerns that we have are usually centered around the amount of particulate material uh, in the air. All right, nitrogen and sulfur oxides. So they are primary pollutants. Okay, they're gases typically produced through some sort of heating or combustion process. So nitrogen oxides form when you're typically at high temperatures, right? So if internal combustion engines, for example, they're reacting a hydrocarbon with oxygen gas, but because our air is primarily nitrogen, nearly 80%, those high temperatures can also instigate reactions between the nitrogen gas and the oxygen gas, get them to form nitrogen oxides, right? So this is referring to a class of chemicals often written as NOx, right? Meaning we might have a various combination for a certain number of nitrogens to a certain number of oxygens, right? So NOx, when you see that, just referring to nitrogen oxides in general, might be NO or NO2, et cetera, et cetera. Those are all nitrogen oxides. All right. Um, so probably the most famous case, and maybe you guys are a little young at this point to remember, but Volkswagen got in a lot of trouble for trying to cheat on their nitrogen oxide emissions testing. We'll read an article about that. It's kind of an interesting one. It involves chemistry, my second love, right? But so nitrogen oxides are greenhouse gases, right? They are a respiratory irritant, and they contribute to something that we will talk about soon as well called photochemical smog. All right, can also lead to acid rain too. uh, when they react with water vapor to form nitric acid or nitrous acid. All right, sulfur oxides. So those are produced by interactions between sulfur and oxygen. Our primary sources of sulfur oxides would be smelting of minerals to purify them into metals. That releases lots of sulfur oxides. Burning of coal releases sulfur oxides, as does diesel fuel. So we have pretty strict regulations on sulfur content that's allowed to be in our diesel fuel. Uh, but there's still a significant contributor there. All right. The main worry with sulfur oxides is they are the primary pollutant that leads to sulfuric acid in the atmosphere and acid rain. All right, carbon oxides and hydrocarbons. So carbon oxides would include carbon monoxide and carbon dioxide. We've talked about the issue with rising carbon dioxide levels in the atmosphere a lot already this year, so I'm assuming you guys remember that. Carbon monoxide, however, more of an indoor air pollution problem, but it can also become problematic uh, in the outdoors. But carbon monoxide is a very dangerous gas because what it does is it bonds to uh, iron in hemoglobin, right, and prevents us from being able to carry oxygen throughout our bodies. All right, and then hydrocarbons are referring to any combination of carbon and hydrogen. Okay, so this is sort of a general formula. But so we could have methane, we could have ethane, propane, butane, right? And a whole variety of different compounds. A lot of our volatile organic compounds, VOCs, that again are more of an indoor air pollution problem. Uh, uh, right, those are a class of chemicals. Some of them are greenhouse gases. Some of them contribute to things like photochemical smog. Some of them are toxic when inhaled. All right. And then, of course, we have ozone. And I told you we'd bring this back in here in a little bit. For now, our focus on ozone is just distinguishing between the good ozone and the bad ozone. And the way to remember this is ozone is good up high, but bad nearby, right? So we know that we need ozone up in the stratosphere. It is essential because it screens out harmful ultraviolet radiation, particularly of the UVB and C variety, right? Exceptionally harmful types of ultraviolet radiation that would cause severe damage to living tissues if it were allowed to make its way all the way down through the troposphere to the surface. All right. So stratospheric ozone is good up high, right? But we say it's bad nearby because we don't, down here in the troposphere, we don't really want to be breathing in tropospheric ozone. All right. It leads to all kinds of secondary pollutants that can lead to things like photochemical smog, again, that we will talk about later. Okay. So in the troposphere, right, ozone is considered a pollutant. In the stratosphere, it is considered essential. All right. So let's chat briefly about the health impacts of air pollution. All right. So sulfur dioxide and particulate matter. Uh, Breathing those in can irritate your respiratory tract. It can impair the ability of your lungs to exchange gases. So I'm not an anatomy teacher, but when you take a breath in, right, the idea is there's an exchange. Oxygen goes into your blood, carbon dioxide leaves your blood, and we breathe out. That's why there's more CO2 than what we breathed in. Okay, when these materials get lodged in your lungs, it can impair that ability to exchange oxygen in and carbon dioxide out. Leading to less effective breathing, if you will. Okay, nitrogen oxides can cause airway restriction. Sometimes they cause your bronchial tubes to become inflamed, uh, making it harder to breathe in. All right, carbon monoxide, as I mentioned, is really dangerous. It basically prevents your blood from being able to carry oxygen to your tissue. So basically, the way this works is if there's too much carbon monoxide in the air, it can lead to initially headache and fatigue, but then you fall asleep. And in some cases, if we don't get the person out of the area of carbon monoxide, they will just slowly die because they're not getting oxygen. Really dangerous indoors, right, where carbon monoxide levels can build up to certain levels. Why you should never, never, never uh, have an unventilated gas stoves in your house. You should never bring in like a extra propane heater indoors without proper ventilation. Okay, or propane cookers because they produce carbon monoxide, and that can slowly cause you to just get a headache and fall asleep. And then it can cause all kinds of problems. Most homes these days, and in fact, it's required by code, have both smoke detectors and carbon monoxide detectors, especially if you have natural gas heating for like water heater for your furnace and things like that. Okay, ozone itself, as we mentioned, good up high, bad nearby, right? It causes burning eyes, coughing, and chest discomfort, and also can be damaging to plant tissues. All right, so pretty cool little graphic here that shows some of the impacts of chronic uh, air pollution. So people that live in areas of high air pollution. right? So particularly our people who are more at risk would be pregnant women, people that already have lung disease or diabetes, right? Really active people because they are breathing in more deeply and more often, seniors and children. So often, right, when we have those bad air quality days because of excess wildfire smoke, they're usually telling children and infants and seniors and people with lung problems to stay inside. Likewise with pregnant women, and they're telling you to limit your outdoor activity level, right? This is why, all right, because those are the people that are most at risk. And what it can cause is things like asthma, right? But in the case of pregnant women, it can cause premature birth, increased infant mortality. People who already have heart and lung disease problems, we see increased incidences of respiratory illness, lung cancers, premature death, heart disease in people that live in high air pollution areas. And that's why we have things like the Clean Air Act to help mitigate some of this. All right. Uh, quick recap: anthropogenic sources of outdoor air pollution, and we will talk about the Clean Air Act and exactly what it does to help clean up our air later. But our primary sources: transportation. So vehicle exhaust is probably our single largest source of air pollution, anthropogenically speaking. All right. Uh, Fuel combustion that's not in vehicles, and so coal burning fire plants, other industrial processes, and so on. So basically, burning things is our primary source of air pollution in the U.S. All right, but forest fires, while naturally occurring because human activities had made forest fires become worse through fire suppression, so fuels build up, making forest fires worse, and also some links to increased length of a fire season because of climate change. Theoretically, as forest fires become worse over time, we can link some of that to anthropogenic sources as well. And again, if you live in the Pacific Northwest or the Western United States in general, you are well familiar with wildfire smoke season.